All right, what's up, lads? We back at it again. We are actually back in Hong Kong now. Just landed today, 6 hours ago. Actually not 6 hours sorry, 4 hours ago. And then we back at it again. Leak code every day. Yeah, didn't do a lot today. Just hung out with Uncle this morning. Hopped on the flight, and then we back. And then I feel like I'm still very sick, honestly. So yeah, tomorrow I feel like we'll get a good lock-in sesh in. Yeah. So today let's do some leak code, and then I would want to make some progress on ALU as well. Um, which is the project two of this. I don't know if I have these here. Oh, it's on my laptop. Jeez. Okay. Um, yeah, so it's not actually in my browser library. So this is a problem with not having an account. Right. Having an account would be very, very nice, to be honest. Um, but they don't have it here. Oh, it's fucked. What's going on? Um, yeah, yeah. Compiler. I think these are for the second part of the course. Could be wrong. Um, but yeah, ALU is definitely what I want to do. So maybe I'll just record that on my laptop because I have all the chips there. Um, yeah. Yeah, these ones have to do. Anyways, yeah, so let's do this one, I guess. Sort colors. Given an array nums with n objects colored red, white, blue, sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, and blue. Okay, we'll use integer 0 for red, 1 for white, and 2 for blue without using the library's sort function. All right, so I just have to sort it, right? Um, One pass algorithm. I think this would be using the partition thing for quicksort. Um, I think. So what it does is you do call it recursively. You don't call it recursively. I don't think you call it recursively. So for int I equals to 0, this is a good refresher for um quick sort and all that shit. So nums dot size. Um, and then plus I, and then you also have a J, I think. Oh no, but then the partition will be one, right? I think you will partition at one. Um, yeah, okay, let's see if this works. Int J equals to 0. Um, and then you would go if I can partition it twice, but I don't think that works. So how would I do this? What's another sort algorithm? There are a bunch of sorts, right? There's quick sort, bucket sort maybe? Um, bucket sort, is bucket sort one pass? I'm thinking zero switches with two, and we'll switch. Um, yo. Oh, right. If I partition it according to one first, right? If nums I is smaller than one, then nums j will equals to nums I, and then plus plus j, right? Mm-hmm. I think. So let's say it's 2, 0, 2, 1, 1, 0, right? So it imagines this. So I and j are both here. J, right? So I is smaller than one. So I is not smaller than one, right? So this will increase by two. This will go to the next one. This is smaller. Yo, Juma, Juma, my friend. Juma, what's another? Oh, Jordan, what Jordan, what? Mm, mm, mm. What is the partition function for sorts? Is that how I do it? Partition, quick sort. All right, I found a pivot, and then um, so what's the pivot function? Right, I don't think I'm wrong. Uh, partition function. C gaga. How do I implement it? Quick sort partition. Right. So pivot is the end, right? Oh, yeah, I don't need the count to be returned. There's only I minus minus. I don't really remember what the cheese is with, like what to swap with what. Right? This is what I was thinking. Oh, like two pointers. I remember there being two pointers for the partition thing. I equals to J. Array J. Right? So I swap I and J. Yeah. nums J 等于 nums I. And then plus plus J. And then at the end, what I would do is I would swap uh swap nums J. 방금 따라서. Oh, oops, my bad. My bad. Means will I lose all my code? I would not. So what really happens here? Ling ling yi yi yet yet ling ling yi. Yeah, I think something fucked up here. So what I'm doing is, if num's I is smaller, it's not. So I go next. And then if num's I is smaller than 1, it is. So this will become 0. This plus is, then this is not, it's not, it's not. So 0, 0, 2, 1, 1, 0. But that's wrong because what should happen is, so it should be swap. Like that. Okay, so what's happening here? So, so this is not smaller, so I plus. This is smaller, so this will become 2, this will become 0, plus plus. This is not, this is not, this is not, this is not, this is, this will become 2, this will become 0. That's not what I want. It does get all the 0 at the end. Okay, but what if I run it through again? What if I run it through again, and then now I do it with 1, right? 1, so it is smaller than 2, sorry. Smaller than 2, it is smaller than 2. It is smaller than 2. It's not smaller than 2. It is smaller than 2. And then I'll run it one more time. And then I feel like I simply run it one more time. But this time, do it with Did that work? And then now I have this, right? It is smaller, so I swap. It's not smaller, or it is smaller. It's not here. Return. Oh, I don't need. But it's a two-pass solution, so it's no good. Yeah, so this is using the partition thing, right, from here. But this is no good because it's a two-pass solution. It runs two times. Oh, it's actually not that bad. Yeah, it is constant space because yeah, but the using one pass, I'm using only constant extra space. So I would assume it's like something of a bucket sort. So you sort it and then you paste it back, something like that, I would believe. Um, yeah, but I did the bucket sort. Let's see if there are any smarter solutions. Right, so let me just talk through the solution first. So what I did here is you start off with this, right? This is what you start off with. And then basically your pivot would be one, right? And if it's smaller than or equals to one, then you will put it on the left. Smaller equals to one, then you will put it on the left. Meaning, like of within the bunch quest of uh of numbers that you have, what you would have after the first pass is that you would have a bunch of zeros and ones here, right, that are unorganized, and then all the twos here. Because all the ones that are smaller or equals to one will be on the left, right? And then everything bigger will be on the right, so twos, right? So what you want to do here is you want to, again, use the pivot as zero, so everything smaller or equals to zero would be on the left. And anything bigger than zero would be on the right, meaning the second pass would sort all these out, right? So, and then after everything, you would end up with a sorted 0, 1, 2. Then I guess for if there are more, like 0, 1, 2, 3, 4, and if there's four, then you would have to, like here is 0, 1, 2, right? So three different categories, you would have to run it through two times, so n minus one time. So if there are 0, 1, 2, 3, 4 meeting five times, then you would have to run it four times, etc., etc., etc. Um, don't think this is optimal solution because it's two pass. Hmm. So let's see. That's what I was thinking as well. Yeah, so it's extremely similar to what I was going for, but they used three pointers, which is smart, honestly, which is very smart, right? Um, that's not that's very smart. So using three pointers instead of running it two times, very smart. Yeah, it's not two pointers. Counting sort. Yeah. In n equals to nums dot size count equals to 0. Hmm. I want to know the frequency one because bucket sort uses frequency, right? I think if I am not mistaken. Yeah. So you would count all the frequencies. Okay, yeah. Yeah, that's not that difficult. But again, you're going to pass. Right. This is the Dutch flag. I wonder if this is quicker, to be honest. I wonder if the solution is quicker. Oh wow, it's even worse than mine. So my own solution is actually kind of goated then. That's what you're saying. Is that what you're saying? Okay, honestly, it's very beautiful. Okay. Well, that is my daily lead code question. I will try and do this now. I'll try and reject it. Ah, all right, let's try this. Okay, so what I need to do is if zx equals to 1, set x equals to 0. Um, right. Jesus. This is like this makes it very easy, but how do I actually implement an if gate, right? Uh, so I think the input would be ZX. No, 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 no. Input would be X. So ZX is just one bit, right? Um, so I'm thinking, I'm thinking using and, something like and. So if I and, right, if I and 16, and this would be 16, and then B would be, that X, and out would be temp, would be ZX out. Something like that? 0 to 15, different bus widths. Hmm. Um, so I need to uh weave this one bit into 16 different bits. I have to replicate it. How? How would I do that? So which chips am I going for here? Mux or X or not? I mean, I can do it with 16 different lines, but I don't think that is the way to do it. Like the quickest way. There has to be a smarter way to do this. Um, turn one bit into 16 bits. Those ones I've all done. But the ZX, if I can do ZX, I can do ZY. If I can do, okay, now NX is pretty easy, right? Like once I have this, then I can do NX. And then once I have ZX, I can also do ZY and NY. Um, but how do I do that? Um, ZX gates. What is the syntax here? So now I have all the bits of X. B, I need it to be like this. Mux is like a choose. Oh, I can do Mux 16. Exactly. I can just do Mux 16, right? Nope. If I just use Mux 16, right? A would be A16. E would just be false, right? Selection would be ZX. Out would be temp would be ZX out, right? Not 16, sorry. This will be 15. What? 16. Right? There we go. Um, so this takes an X, and then B will be false. And if selection one, Mach 16. If selection is 0, then it's A. If 1, then B, right? If selection B, else A. If selection is 0, then you output A. If selection is true, you output B. If selection is 0, you output A. If selection is 1, you output B, right? True. Okay, beautiful. Then I would have also have Y. This is ZY. Then ZY out, right? And here I'll have to negate the X. I'll have to negate the X. So this will be not 16. If NX is true, so it will also be Mach 16, right? I think. If if this is true, right? Okay, yep, that's right. So it would be Mux as well. These are all Muxes, right? Selection would be NX. And it is false, then I will just give ZX out. And if it is true, then I would have not. I'll do that. Is this not a valid um guess I have to do this then? Not ZX out. Okay, that seems pretty legit. And then I will have the same thing for for Y. Okay, so I have these four done, right? I have those four done. So this would be ZX, and then this would be X. This would be ZY. This would be NY. And then now I have to do F. Compute. Okay, so this would be a mux once again. The selection would be F, right? Out would be the output processed. This would be pre-output, I guess. I don't know. And then what I want here is X plus Y, which would be add, right? Add 16. This would be X processed and Y processed. This would be X plus Y. If F equals to 0, then I'll output A. If F equals to 0, I'll output A. So this would be B, right? Right. So this would be X plus Y. This would be add 16. Oh, 16. Six, five, six. would be X and Y. Y. Which one? Okay, here we go. That was done. Yo, 좀 뭐가나? No would be this. Would be something like this, right? So not 16. In would be pre-output. Out would be not pre-output. And then I would get a mux 16. Selection would be no, right? Negate. If it's 0, then I'll just go pre-output. And then if it's 1, then I'll go not pre-output. Output will simply be output. Oh, sorry. Out 16. Beautiful. And then I'll also do the ZR. The ZR is if out equals to 0,16. If it's equals to 0, it equals to 1, else it's equals to 0. If 零就等於一 anything else 就等於零 So I just have to hit it with a not, right? I believe. What does not 16 deliver? Isn't bit by bit though. Because honestly, I'm thinking not 16, and then I just do out, right? 0 to 15. This, output in its input. Okay. Mm, everything should be right except for the last pin. Um, I think, right? These are all correct. It's just these pins which are wrong. Outputs. Right. So it's just the pins that are wrong. It's just these two that are wrong. Which is a good thing. Um, yeah. Um, I don't know how to do this. So I need to compress the output. Final output. Not. And then I put in the input. Wait, am I stupid? Oh, but it ors all the different ones. Right, right, right. So that's the problem, right? Um, Here, let me think. Let me think. I use must as a selection, right? That's one bit. Um, but then now the selection has to be, mm, but increment output by one and then equals to one. Wait, no, that's stupid as fuck. No, 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 no. How do I do this then, really? Or eight way. Or. Oh, oh, or eight way. Okay, let's see. So I do or eight way. In will be, output link to link 1 2 3 4 5 6 right? Would be first half or what's wrong? Why? Internal pins cannot be subscripted or indexed. Why not? Literally, why not though? Why can I use output pin as input pin? What if I put this here? Does that work? So it's not really a question of if that can be used. Why not though? It's the final countdown. Du-du-du-du-du. Du-du-du-du-du-du. Du-du-du-du-du. Du-du-du-du-du-du. Du-du-du-du-du. Du-du-du-du-du-du. Du-du-du-du-du. Du-du-du-du-du-du. Du-du-du-du-du-du. Du-du. How do I do this? I don't know how to do the ZR pin. Mux, not a mux. Mux, not a mux. Mux, not a mux. Right. Mm-hmm. Add and mux. Mm-hmm. Not in the mux. Mm-hmm. Or 16 way? Is there an or 16 way? There's no or 16 way. There's no or 16 way, nigga. Oh shit, I'm not supposed to say that. Whatever. So I have to write this over 16A gate. Is that what I'm hearing? There is no or 16-way gate, my friend. What the fuck? Okay, I guess I have to write it then, right? Or 16-way gate would be, yeah, but internal pin wouldn't be able to. Bruh, how am I supposed to do this? Hmm, give me VS Code, man. Okay, I'll open this and then I'll add a or 16 way dot HDL. All right, and then I'll do like this. I will go for eight-way. All right, 16 way, 16. And then, sorry, I'm in, yeah, you can't see what I'm doing now because I'm in VS Code. I guess I can share it. Yeah, so I am in VS Code right now. Um, where this? Okay, do you see it? Yep, you see it. Okay, so what I'm doing now is, um, so what I want to do is, um, or eight-way, right? I want to or eight-way, and then in equals to, uh, in 0 to 7, out equals to first half or, right? And then I want this to be 8 to 15, and then this to be second half or, and then I want this to be or, and then in to be first half or, and then, oh, sorry, this would be A, and then this would be B, which or out equals to out. I believe this is correct because or is A and B and out equals to out. Yep. I will save this. Um, and then I will I'll open an HTML file. Um, oh, can I not, bruh? Can I not do this using this menu? Well, uh, okay, so I feel like this chip works. But then how do I input it back to this is my question. Load a test script. No, I want to open an HTML file directly. Local chip. No, projects to cannot include another chip in this. Okay, I cannot. How do I do this? Hmm, I'm out. Mm, 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 mm. Mm, 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 mm. Mm, 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 mm. What one thing deep, dun, 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 oh, 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 oh. 习惯都就飞吧。嗯 don't really understand, if I'm being honest. Go to Fabian. This is the part that I don't get. Like, what the fuck is going on here? Right, so out would be out, literally. And then it would be this. Don't really know what's going on. Don't really know what's going on with the syntax, if I'm being honest. First, second, right? Oh, so we're creating a new variable here. Ah, okay, I see.啊，我切咯，我唔想咬我餅。哇，咁正嘅呢個嘢，係啊，咩嚟㗎？呢個係？你尋日啱啱買嘅。哇，我肥到爆！呢個抵唔抵炸㗎？啊，抵唔抵炸㗎？呢個係？麵包 OK 啊，冇纖維嗰種啫。你自己食啦嚇。哦，thanks. Thank you. This would be set R verse. This would be set R second. Set R. Okay, cool. And then NG. Okay, now I get what's going on. Um, now I know what's going on. So this one is a fan. And here, you're taking the first 8 bits and making a new variable called this. Taking the last 8-bit, making a new variable called this. Making taking the last bit and then making a new variable called this. I see. Didn't know you could do that with the syntax, but apparently you can. Okay. So Out is smaller than 0, but we're using 2's complements. So how do I do that? So what's special about, oh, it's the last significant bit, huh? And then the last bit is the most significant bit. And if it is 1, then it means it's negative, I believe. That is my hypothesis. So I'll go and then temp out and G, right? B would be uh we'll go 4. Oh, just let me, bro. If it is smaller than equals to 1. If it is smaller, if there's 1, it will be 1. Else is 0. I believe that's correct. Is it? Ooh, what's wrong here? Okay, the NG seems to be right as well. Oh, so AR. We'll have to knot this as well, huh? It's all correct. Beautiful. I did it. I did it. Okay, I didn't know how to do the ZR and NG because I didn't know the syntax. Once I got that, it was pretty simple, right? Um, yeah, so these ones I don't need to explain. It's pretty much self-explanatory. Not pretty self-explanatory, and then I take the first 8 bits and then I find the or the first 8 bits, or the last 8 bits, and then I or those two. So if any of them are 1, this will give 1, and then I need to knot it because you want ZR to be 1 when output is not 1. You want it to be 1 when the output is 0, and then you want it to be 0 when the output is not 0, right? So you knot it pretty much. Right? ZR equals to 1 when x equals to 0. ZR equals to 0 when x equals to uh not 0. ZR equals to 1 when x equals to 0. Yep. Z equals to 1. So when x equals to 0, then I knot it, then it becomes 1. But when x equals to 1, then I knot it, then it will become 0, right? 1. Significant show. Yep. So I nodded. Beautiful. That's what I want. And then NG is or. So if the first significant bit is 1, the most significant bit is 1, then I want it to be 1, right? Because when it's negative, I want it to be 1. When it's negative, I want it to be 1, right? And negative meaning the most significant bit is 1. So when it's most significant bit is 1, I want it to be 1. Great. Yeah, I think everything is looking good here. Great. Yeah, so this is ALU complete, and ALU is one step within the one step within the computing the making the CPU, right? It's just one bit of it. Uh, yeah, pretty interesting. But yeah, I did it. I fucking did it, man. So yeah, yeah, I mean, yeah. OK，进步到这里了，明天继续。Peace. Bye. Getting better. Getting better every day. People at Citadel, people at Jane Street, people at these boutique ass funds. I'm coming for your fucking job. I'm gonna get there, niggas. Not supposed to say that, but who's gonna fucking watch this anyways? Peace.